some, like a branch of physics called kinematics. Okay. So
Okay.
in this kinematics, what you do is you learn about, like what are objects in rest going to behave like, what are the objects that are in motion going to behave like. Okay. And how would you, like describe motion in straight line, what are the laws of motion and all of that. Okay. So that is one thing that you will be studying. Okay. And
Okay.
then work energy and all that, so that is also. And then you'll be learning something called fluid mechanics.
Okay.
Okay. So usually anything that flows, okay, is called a fluid. So your gases as well as liquids, both of them come into this particular category. Now associated with this, okay, you have certain mechanical behavior, okay, associated with your fluids usually. So either, like pressure of the fluid or different ways in which, different laws can talk about the flow, the presence of fluids, right? So that is dealt with in your fluid dynamics.
Okay.
Then you have something called thermodynamics. Okay. And more about your heat, and you might have learned one chapter called calorimetry, right? So that calorimetry's continuation is your thermodynamics. In your 10th standard, you might have that. Okay.
Yes.
So a study of your heat, how heat transfer takes place, what are the different phenomenon associated with heat energy transfer. All this you will study here. And then comes your wave mechanics. Okay, so we talked about a lot of motion in kinematics. Okay, one motion that we do not talk about here is the to and fro motion, like a pendulum or a stretch spring or something like that. So
Okay.
that is dealt with in your wave mechanics actually. Now if you look at it, this whole thing will be in your grade level. Okay. And if you see your grade 12, okay, so your grade 12 majorly focuses on the concepts of electricity and magnetism. Okay. So in electricity and magnetism, again, see, usually there is a analogy they derive between mass and charge. Okay. So you'll be talking about charges in rest, charges in motion. Okay. Then how when it flows through it forms current. Since you have just finished 10th, okay, you might be relating to electromagnetism also. How electricity induces magnetism, how magnetism can create electricity, right? So this is a very vast branch, and most of your topics, okay, most of the topics in the second year that you're going to get, like 12th standard, is attributed to your electricity studies only. Okay, most of the chapters come in there. Okay, then additional to this, you have something called optics. Okay, and in this optics you study about different light based phenomena, be it your reflection, diffraction, okay, particle nature of light. And then you start studying about how, like wave behavior is exhibited in phenomena like interference and all that. So you'll be studying all of it. Okay, and then there are one branch which is called nuclear physics. Now, in your nuclear physics, you will be more inclined towards studying, how what is the wave behavior or something which is exhibited by subatomic particles. Now, I agree that you might have studied like atom comprises of electrons or protons or whatever subatomic particles are there in your chemistry.
Yes.
Okay, but how do they? How were they discovered and confirmed by physics? Okay, what are the different behavior that they exhibit, right? So be it the beta wave or the alpha wave or whatever wave like behavior, whatever they are exhibiting, how they are exhibited, right? So that is actually confirmed and studied by your nuclear physics. Then the
Okay.
last two units, okay, your semiconductor physics, okay, and your communication system. Now, both of this, if you see, this is the, like this is the thing that falls in the category of electronics and communication. You might have heard many people talk about this, right? I'm ECE branch, I'm telecom branch, and all that in engineering. So most of this electronics and communication is covered by your semiconductor physics and communication system chapter. Okay, so this is how the entire syllabus is actually organized. And if you see grade 11 physics, this has the maximum weightage. Okay, it has like around 12 marks weightage. And if you see grade 12 physics, okay, this has around 12 marks weightage.
Okay.
Okay. And as far as your syllabus, NEOS is concerned, you'll have certain assignments that you do, they are graded for as well, isn't it?
Yes.
Now, are you following up all this with any lecturer or anyone?
No, not.
No? Okay. So we'll have to talk about that also. Okay. Anyway, we'll take that up later. So usually there is some tutor mark assignment component, okay, in your syllabus. And then, like certain worksheets have to be solved or something like that, right? So based on that, you'll be getting some marks. Then you'll be writing this and select few practical things also you will get. And there are some optional modules also, right? So 10 marks each optional modules are also there, okay, which you get to choose and all that. Okay. All right. So that being said, okay, so today what I'll do, I'll start off with, okay, also when will you write your exam? Can you just confirm to me?
And I think it's September, October.
September or October for your grade 11 part, isn't it? Okay, got it. So yeah, so like mostly we'll be starting with kinematics itself now. And once you're sure, okay, of further classes, first we'll chart out a schedule for you, because usually what happens is we work with March, April, that kind of a timeline, isn't it? So their exams might be in March or something, but for you it might be earlier. It might be in September. So accordingly, we'll plan on that. Okay. All right. Then. So let me do one thing. So, like just for the demo class purpose, okay, the topic that we will be dealing with today is how do you derive three equations of motion. Okay, so I'll be taking this today. And of course, chronologically, this is not the first topic, but I just wanted to take this, okay, just so that you understand how the class works. So I just want to understand one thing from you, okay? What do you call as motion?
Anything that moves.
Exactly, right? So anything that moves is said to be in motion, or movement, okay, is actually termed as your motion. Now, there are multiple different kinds of motion that we come across, okay? So for example, let's say there is a road, okay? And there is, like a car moving on the road, okay? Now, this car is actually going to move either towards your left or towards your right, isn't it? So have you ever noticed any car moving up and down?
No.
No, right? So this is only one dimension. Why we say one dimension? Because in your Cartesian coordinates, okay, we have x-axis, y-axis and all that, isn't it? In that, only x-axis will be enough to describe the motion of this car, isn't it? You don't need a second axis at all.
Yeah.
So this is motion in one dimension. Now suppose, okay, the same way I come to a ball, okay, let's say there is a boy. By the way, which sport do you play?
Tennis.
Tennis, okay. So let's say, like a tennis racket itself hit the ball, okay? Now this ball takes a path like this, isn't it? The trajectory is like this. But for this, okay, let's say a ball at a unique position at this point is having a, like a displacement, okay? It has moved both in x direction, okay?
And
And also it has a height associated with it. It has moved in y direction, which is your vertical direction as well.
okay.
Meaning there is also a horizontal component to it, okay, and there is also a vertical component to it, okay. There's a horizontal, there's a vertical component. There is both to it, and this is actually called two-dimensional motion. Okay, two-dimensional motion. So x as well as y direction. Okay. Now, of course, there's one more category where we talk about the to and fro motion, isn't it? So, like I told you, the pendulum. Okay, there is a mean position. There are two extreme position. Okay, extreme one and extreme two. So, how are you going to move to and fro, right? So, this is what we deal with in wave mechanics, actually. Okay, the to and fro motion. Okay. Now, we confine our entire study only to this for time being. Okay. We are going to experience motion only in one dimension. Now, what are the possibilities that we can have? Okay, we'll discuss about that. I want you to first familiarize yourself with a few terms. Okay. So, one is your displacement. Have you heard of this term,
Shortest distance
displacement?
between two points.
Pardon me?
Shortest distance between 2 points.
Exactly, right? So shortest distance. So what we mean by shortest distance is, see, let's say you are here, okay, this is your home, and let's say this is your school. Okay. Now, your school to home might just be 2 kilometers. Okay. But let's say they have, dug this road or something. Okay. You're going to take a round about somewhere within the streets and all that, and then reach your school. Now, this will give you the distance.
Distance.
Okay. So you might have actually, you might have taken 5 kilometer stretch here to reach your school. But that is not the displacement. That is not the shortest path to your school. So shortest path is your distance only, always. I
Displacement.
mean the path distance alone, okay, which is going to be 2 kilometers.
Okay.
Okay. Now, there are two things. Okay, one is your speed. Let's say there is a particular car which covers a certain distance in a particular unit of time, then it becomes speed. Suppose you have like one more, like one more car or something, which is covering a displacement in a particular time, then that will be called as velocity. Okay, that's the difference between speed and velocity. So the way you are knowing the difference between distance and displacement, there is something that you have to be able to differentiate between speed and velocity. Also, there is one more mathematical aspect coming here into picture, which is called a scalar or a vector. Okay, have you heard of these scalar or vector?
Yes, one time. Yeah.
Okay. Yeah, but this is a whole, new big topic if I have to take,
I
so I'm
think
not
it
touching upon it. Pardon me?
I think I heard this in ninth.
Ninth, okay. Right, so it comes with direction component. Okay, so I'm not dealing with it right now. For simplicity's sake, we'll just know that velocity is displacement right now. Okay, so now I have certain parameters which are coming as variables to describe a scenario. See, always your physics is a branch of science which does measurements, which observes certain things and tells what are the components required to describe a particular thing. Now, suppose we consider a car in motion itself. Okay. So, here, what all physical quantities are coming in to describe the motion in one dimension? First of all, displacement covered by the car. Okay, displacement is represented by S. Okay, and what is the velocity or what is the speed with which the car is moving? Okay, so that is actually taken to be V. Now there is one, like component here. This will be the final velocity. Now suppose we are talking about the car which is initially at rest. Let's say the car is initially at rest, then it acquires the speed and starts moving. Initially it was at rest, no, it was not moving, no. So that initial velocity will be zero, and that initial velocity is taken to be v. Okay, and the duration for which, okay, the car will be in movement, that is your time. So this will be taken as. So these are all the different variables using which you can describe your entire one-dimensional motion. Is that okay?
Yes.
Your entire one-dimensional motion you can tell. Okay. Now we represent these in graphs also. So graphical representation is very, very important, very, very useful in understanding a lot of things. Okay. Even if graphs are not your strong point, okay, make sure you brush up your graphs because it will solve most of your hindrances. Okay, if you understand graph very well. Okay, we'll take one example. Okay, let's say I represent the distance. Sorry, time is always x-axis. Okay, I'm really sorry. Yeah, represent the time on the x-axis. Okay, and displacement on the y-axis. Okay. Now, case one. Let's say at the end of first hour, second hour, and third hour, I'm going to actually mark the position of the car. Let's say this is 5 kilometer, this is 10 kilometer, this is 15 kilometer. Okay. Now, at the end of, like 1 kilometer also, the car is, at zero velocity only. here also it is at zero velocity only, and here also everywhere it is at zero velocity. So what can you tell about the car?
The car is at rest.
Very good. So this is car is at rest scenario where it's a straight line graph parallel to the parallel to the x-axis. Now we'll take another scenario, same kind. Okay, so this is case 2. Again, time on x-axis. Okay, displacement on y-axis. Now at the end of the first hour also it's covered 5 kilometer only. End of second hour also it's covered 5 kilometer only. End of third hour also it is covering 5 kilometer only. Okay. So what can you tell about this particular case?
Moved 5 kilometers and then it's at rest.
Yeah, in each interval of time, it is moving 5 kilometers ahead.
Okay.
Okay. So if you take, the this thing, if you take the speed, okay, if you have to calculate here, how will you calculate? You'll calculate speed or velocity as displacement divided by time, isn't it? So the displacement is 5 kilometer in 1 hour. Okay. In this hour also, it is 5 kilometer. And in the next hour also, it is 5 kilometer. In the next hour also, it is 5 kilometer. Okay. So this is going to be 5 kilometer per hour throughout. Okay. So this is, where you're moving with uniform velocity. Okay. This is the second case. Now, the third case is a little different. Okay. So what is the third case that we're going to see? So let's say it covers 5 kilometers, 10 kilometers, okay, and 15 kilometers. Okay. So this is your x-axis. This is your y-axis. Okay. Now let's say this is displacement. This is your time. Okay. Now at the end of the first hour, it has covered 5 kilometers. But at the end of the second hour, it's covered 10 kilometers. But at the end of the third hour, you see it's covered 15 kilometers. So it is a slope. I mean, it's a slanting line,
So it's
slope
increasing.
line like this. Huh?
So it's increasing.
It's increasing, exactly. But how is it increasing? It's increasing in a very constant something. Okay. For example, let's take the duration, okay, 0 to 1. Now, in this interval, what has happened? If I have to calculate the velocity, I calculated as S2 minus S1 by T2 minus T1. So, what are this S2? So, let's say this is S2, which it has attained. This is S1. This is T2, this is T1. Okay. So this will be 5 minus 0 by 1 minus 0. So this is going to be 5 kilometer per hour. Okay. But what is happening here? Next, what is happening? You're going to take again. Okay, these two intervals. Okay, so here S2 minus S1 by T2 minus T1 again. So here also it will be 10 minus 5 divided by 2 minus 1. So what will you get again? This is also going to be 5 kilometer per hour. So here it is moving with a constantly increasing velocity, non-uniform velocity. But what is constant is a quantity called acceleration. So this 5 kilometer per hour is maintained across all durations of time. So velocity by time, okay, is actually called your acceleration. Okay. And at any point of time, suppose you want to know what is the distance covered. Okay. Effectively, what is the distance covered? How will you calculate it? So let's say I want to calculate the distance covered in 2 hours. Okay. What do I do? I want to know the distance. So this is 10 kilometers, isn't it? But how will I get it? Right? How am I going to get it? So if I find out the, if I find out the area covered by this triangle, okay, that will give me the distance. So if I find it out by half, base, okay, base is 2, height is 10. Okay, so 2 ones are, so I'll get 10 kilometer. So this is the distance covered by the car. So this is another thing that we have to absorb from the graphical representation. So one thing we understand right now, okay, I'll just tabulate whatever we understood right now. Okay. So if at all the car is traveling, okay, it will have an acceleration component. And there are cases where acceleration is non-uniform also. Okay, that is the next thing that we will deal with. Or acceleration also could be non-uniform. Okay, but it will come with an acceleration. Okay, and acceleration is given by slope of the graph. It will cover some displacement, and this displacement is going to be given by area under the curve for your, or area under the graph, you can take. Curve or graph means the same thing. Area under the graph for your displacement time graph or velocity. Velocity time graph. So all this, like we have to keep in mind. And then we have the initial velocity. Okay, so this is going to be represented by A. This is going to be represented by S. Okay, this is going to be represented by initial velocity. It's going to be represented by U. And the final velocity it acquires. Okay, that final velocity will be taken as V. Is that okay? Now, we require three laws of motion to describe and find out various, things that we have just tabulated. Okay, we require them. Okay, um, three laws of motion or three equations of motion, not laws, three equations of motion. So we are going to derive these three equations of motion now. And for that, we are going to take a graph, and from that we are going to derive. Okay. So there are algebraical way of deriving it. Okay. Graphical method of deriving it. And also you have one method called uh, deriving it through calculus. Okay. So that will be the other method. So we are going to stick to the graphical representation right now. Okay. So let me put up this graph. Okay, so I'll just explain what will happen in here first. Okay, so if you see, this is a velocity time graph. Okay, the velocity is represented on the y-axis and time is represented on the x-axis. Always, for most of the cases in your physics, time will become the x-axis. Okay. Now, it is starting off with the initial velocity. Let's say this is, 5 kilometer or something. It's starting off with a velocity. So this part, okay, is called the y-intercept. Okay, and y-intercept is your initial velocity, u. Then it acquires the final place with the final velocity, and this is your v. Okay, this whole thing is represented by v. V is your final velocity. Now with this in place, okay, what we are going to do, we are going to start seeing how three equations of motion you can derive and how do they fall into place. Okay. So let's do one thing. Let's take this part that I highlighted. Okay. Now I want to know what is this V. Okay. So how do I do it? So I know that this whole line is BC, which is given by BD plus DC. Right? Now, what is this entire BC? This is your V. Now, what is BD? We do not know, right? We don't know what is BD, so I'm going to keep it as it is, okay? BD. Now, what about this? Okay, DC. This is going to be U, okay? So, how do I get my BD? Any idea?
B.
BD. So what I'm going to do, I'm going to use that acceleration as the slope of line. That, a concept I'm going to use here. So what is my acceleration? A. This is going to be slope of the line.
So AB.
So how is your slope of the line given? It's given by BD divided by AD. Agreed? So your A is equal to BD by AD. Now what is your AD? AD, this entire stretch, is going to be T. Okay. So A equal to BD divided by T. Now what has your BD become? It's become A multiplied by T. Suppose if I multiply this, it's going to become A multiplied by T or AT. So let's call this equation 2. Okay. And what am I going to call this? I'm going to call this as equation 1. Okay. Now what I'm going to do, I'm going to substitute